This is the Building Automation Monthly Podcast with Phil Zito, episode 143. Hey folks, Phil Zito here, and welcome to episode 143 of the Building Automation Monthly Podcast. In this episode, we are going to be talking about a topic that has been really not talked about, as far as I can see, anywhere out there, but yet is a really important topic, and that is smart equipment, and more so, how to work with smart equipment. So what is smart equipment, and why do you need to know about this? Well, smart equipment is where you're taking controls and actually embedding them in the equipment. Now, this is different than factory-mounted controls, where you send your controllers to the factory and they mount them on the piece of equipment. This is actually equipment with its own controller board built in. You see, it's real interesting as an industry that we're almost basically cycling back to where we started at. In the beginning, we had these things called application-specific controllers. And application-specific controllers served a specific application. And basically, you would go through, initially, it was dip switches. You would flip some dip switches, and that would go and determine what application was running on the controller. And then it got to the point where you actually had software, and you would pick kind of what functionality does this piece of equipment do, and then the controller would go and have kind of this pre-canned code inside of it. Well, as we're running into kind of a skill shortage, and we're starting to see that the cost of getting technology embedded in equipment is quite low, and companies are looking for a way to kind of capture data from the equipment, monitor the equipment, and then build a revenue model around kind of proactive service and monitoring. So we're starting to see smart equipment. We're starting to see those application-specific controls come back in the form of smart equipment. So as I mentioned, smart equipment has these controls embedded in them. And then what happens is when the mechanic is doing the startup, they look at what the piece of equipment is supposed to do, and then they configure that piece of equipment based on settings in the software that interacts with that piece of equipment. Now, this is all well and good, and quite frankly, I feel like this is where the industry is largely going to be heading. We're going to have controllers, free programmable controllers for complex systems, but a majority of our systems are going to head towards smart equipment because it's just a way to avoid having the lack of talent that we currently have impact your ability to execute projects. Also, if you're thinking about it from a mechanical contractor perspective, which most of the building automation contractors are subbed under the mechanical, this is a great way for them to cut out the building automation contractor and to be able to do kind of quote unquote the total package, because now they've got this smart packaged equipment and they can have more margin because they're not having to absorb the margin of a BAS contractor. But that's not what the episode's about. It's not about the sales and business strategy around smart equipment. It's actually around the 5 gotchas of smart equipment. These 5 things that I really want you to be aware of, because if you're not aware of these 5 things, you can get really burnt by smart equipment as a building automation contractor. And it's still amazing to me to this day that there are so many BAS folks who struggle with tying in basic integrations from smart equipment. Now, that may hurt your feelings that I said that. I'm sorry, but I'm not sorry if that hurts your feelings. If you are struggling with tying in a BACnet rooftop, or you are struggling with tying in a BACnet interface from a chiller, I think you need to have an honest look at yourself and really evaluate where you are skill set wise, because that stuff, I hate to break it to you, that's some pretty easy stuff. And I'm not saying this to knock you down. Any of you who have been listening to this podcast for any amount of time know that I'm coming at this with trying to help you. So step outside yourself, don't get butthurt, and realize that what I'm doing here, when I'm saying, hey, that's pretty basic, and you need to realize that if you're kind of challenged by this, that is an indication of where you're at skill set wise. realize that that's meant from a place of, hey, I want you to be better. I want you to improve. I'm doing this because I know you're capable of getting there, but probably no one's ever come alongside you and told you these kind of 5 gotchas and said, hey, look out for these things, and taught you what you really need to know. Because let's be real, there's a lot of folks out there who are quote unquote teachers of BAS. And I'm not talking about university professors, or I'm just people who claim to be, hey, I'm going to teach you, I'm going to guide you, but they really don't know what they're doing. So I do know what I'm doing, and I'm going to tell you what you need to look out for when it comes to smart equipment. So the first thing that you want to check is sequence alignment. There's nothing that sucks more than going and doing commissioning. So remember, in a project, right, we create our submittals get approved, we have our installer come and install, we pull the system in. So when we're talking about smart equipment, what we're talking about is our installer is most likely going to run BACnet MSTP or BACnet IP to the smart equipment, and then we are going to map it in, quote unquote, map the equipment in, which we'll talk more about in a second. We're going to map that in to our to our BAS. And then we're going to go and pull it into our graphics and probably schedule an occupancy point, call it a day. Well, the commissioning agent's going to come along and they're going to have this sequence based on the sequence of operations from the specification, usually, sometimes from the mechanical plans. And they're going to say, hey, guess what, guys and gals? We're here to make sure this stuff works according to the sequence. And you're going to be like, okay, that's cool. And then you're going to realize that the mechanical contractor didn't get the right piece of equipment, or the startup guy or gal didn't go and actually check the right things on the box. And so now all of a sudden, this unit that should have a preheat capability does not have a preheat capability. It's actually set up for reheat, even though physically it has a preheat coil, but it's just not operating that according to the sequence. Or the person who wrote the sequence didn't know the capabilities of the equipment, or just didn't give a crap about the capabilities of the equipment. They're like, you're going to make the equipment work based on our sequence. We don't care if it can work or not. And so what happens is now you've got this gotcha of sequence alignment. And this is where you have a piece of equipment that cannot execute the sequence. Now, how do you deal with this? Especially as a technician. Because remember, we're in a rotating 4-part kind of series of these podcasts. We talk through a business, we talk through a sales, then we talk through a technical, and we're on the technical right now. And then next week, we're going to talk about APIs, and that's going to be our kind of IT. And that's the rotation we take here on the podcast. So from a technical perspective, how do you deal with this? Well, in an ideal world, you would be engaged with the contracting tier, and you would, sit down and have all the time in the world to go through the sequence, and you would have great HVAC knowledge, and you would know, hey, the equipment can't operate this way, or that's not realistic. And then you would know exactly what that piece of equipment's capable of, and you could see the sequence misalignment. But that's freaking ideal, and that's fairy tale land. And the reality is that's not going to happen. So you're on a plan and spec job. You get handed this turd of a sequence and or this piece of equipment that could not possibly execute the sequence. What do? Well, this is where you have to go and identify sequence misalignment, and you have to understand how smart equipment works. You have to understand, is this piece of smart equipment, is it where they're configuring settings in the software and they simply did not configure the settings right? And in which case, let me be clear, I don't expect you to know every setting. That's the mechanical or whoever's doing startup. That's their job. But you can at least understand to ask the questions of be like, hey, what settings did you choose? Did you choose the right settings? That way we can make sure that we have sequence alignment. Because as soon as that commissioning agent starts to go through it, and they're going to point the finger at you because you're the controls guy, even if it's smart equipment. Get what I'm saying here? By going and understanding, hey, this piece of equipment is configurable, even though it's smart equipment. So I'm going to talk with the mechanic and make sure the stuff's set right. Or it's not configurable, and this is how it comes out of the factory, and there's nothing I can do short of issuing a change order where we rip out the smart equipment controller and we take control of everything utilizing our own free programmable controller. So this is gotcha number 1, sequence alignment, which brings us to gotcha number 2, which is design accuracy. It's very closely tied to sequence alignment, but it's slightly different. Whereas sequence alignment is making sure that you are configured to execute the sequence, design accuracy is making sure that you're actually accurate in your design. So for example, if you want a air handler to act as a DOAS, a dedicated outdoor air system, or you want a chiller that is going to be a water-cooled chiller, then you need to make sure you design that piece of smart equipment correct. And you need to make sure that you design the dependent systems correct. And we'll talk about dependent systems in just a little bit. So that's design accuracy. Once again, for those of you who are like, I only make $50,000 as a tech or whatever, and you want to get to that 6-figure range, these are the things you need to embrace. You need to go and say, you know what? I'm going to think beyond being just a tech, and I'm going to be proactive and look at the design, and I'm going to understand enough about HVAC and understand enough about controls that I'm going to realize that there's an inaccuracy in the design. So first you've got sequence alignment, and then you've got design accuracy, making sure that the dependent systems are accurate. And we'll talk about that in just a second, like I said. Now, gotcha 1 and 2 can flip in order of priority. Sometimes you'll look at design accuracy before sequence alignment. Sometimes sequence alignment will prompt you to look at design accuracy. But these are two things you should look at. Anytime you see that there's smart equipment, you want to make sure that you go and look at these two gotchas. They can really burn you really fast, and they're often out of your control. You can only suggest, but there's not a whole lot you can do. Which brings us to gotcha number 3, which is dependent systems. So you have to understand what systems are dependent on this piece of smart equipment. For example, if you are doing a smart VFD-driven VAV air handler, and it does not have free programmable controls, but rather it has package controls, then you need to understand that, and then you need to understand what the capabilities of that system are. Because a lot of folks will do maybe a trim and response sequence, or they'll do a zone averaging sequence, or sometimes they'll even look at the valve position and then they'll reset the chilled water supply. There's a variety of dependent systems, both upstream and downstream of this specific unit, that you need to be aware of. And by being aware of these dependent systems, that then lets you know if you can do what is in the sequence. So for example, if you see that there's a trim and response for speed control of the VFD on the supply side of this VAV air handler, yet there is no way to control that in the system, meaning that you can look at all the VAV box commands and or temperature, or however you're doing trim and response. You can look at that, and then you can do a calculation in your supervisory device, and you've got the plus and minus for your trim and response algorithm, but you can't go and send that to the packaged unit because that packaged unit is not got a way for you to adjust the differential pressure set point for the supply fan control. Then hey, the sequence is great, but you can't do it. That's what I mean by understanding dependent systems, both upstream and downstream. Now, I want to go through a couple things real quick because I kind of just flew by that. An upstream system is something that supplies your system. So an upstream system from a VAV air handler would be like a chiller that supplies a chilled water coil, or a boiler that supplies a hot water coil. A downstream system is a system that is dependent on that specific system. So a VAV box would be dependent on a VAV air handler. Thus, VAV box would be a downstream system. A cooling coil is dependent on sometimes secondary chilled water pump and mixing valve, sometimes the actual chiller itself. And so those are dependent systems. And then you hear this trim and response. That's basically where you go and you cut back on the pressure the pressure set point to essentially lower the amount of air volume that is being supplied. You're trimming. Sometimes you can do trim and response for discharge air as well as for pressure. So I will say that doing trim and response for discharge air set point has less effect potentially than doing trim and response for air pressure, because flow dynamics are something you want to be really careful about messing with. You can have a lot more forgiveness when you mess with temperature, but when it comes to flow, you can really hose some things up pretty fast with some just minor changes on CFM, especially if you're dealing with large systems. Okay, so then with all of that being said, we have to think about gotcha number 4, which is system segmentation. And I see this quite often. And folks try to solve the sequence alignment and the design accuracy problem by segmenting portions of the same system. This is a recipe for frickin' disaster. This is where you have a packaged air handling unit, and you're going to control the fans with your free programmable controller, and then you're going to let the packaged air handling unit control the cooling coil. And the two systems are not, if you're not even often talking to one another, yet the process loops inside them are completely dependent on one another. You know, if you are improperly supplying airflow, then it doesn't matter if you're at discharge air set point. And if your discharge air set point's all hosed up and you're not properly controlling your coil, it doesn't matter if you're providing the proper flow to the space. And if there's no way for these control loops to talk to one another, things can get ugly really, really fast. So gotcha number 4 is system segmentation. If you ever see a design where part of the air handler is going to be controlled by the field controller and part of the air handler is going to be controlled by the packaged unit controller, that should be a red frickin' flag. You should be like, oh crap, that's got hosed up job written all over it. I'm not saying you can't do this. I myself have done this stuff in the past, more so with hydronic loops. You know, you have a packaged chiller and then you do pump control. Now that those are more dependent systems than system segmentation as I think about it. I really can't think of a good scenario why you would want to do. Maybe you could argue with energy recovery wheel systems where that's a specific system controller and then you've got a free programmable controller for the rest of the unit. But in reality, the argument for segmenting a system, I mean, it's just fix the sequence. Oftentimes, the reason folks do system segmentation is because the sequence cannot be executed any other way. So that is trying to fix an issue with the sequence by going and hodgepodging the equipment, or you could argue fixing a problem of the equipment to achieve a perfectly good sequence, depending on how you look at it. The point here, though, is to be aware of that, especially if you're a design engineer or an owner or a service person. Be very aware of segmented systems. Now we're going to spend a lot of time here in gotcha number 5, which is protocol integration. This is something a lot of folks seem to really, really struggle with. And in my opinion, it's one of the easiest things to do. Now you may be like, okay, Phil, it's easy for you. You used to be the program manager for system integration at Johnson Controls. So of course, protocol integration is easy for you. Okay. I mean, duly noted. Yeah, I do have a lot of experience, but you know, I was doing protocol integrations way before that, like my first year in BAS, and it's not something that's new. BACnet IP is not some freaking new thing. It's been around for years, decades, and it's the same process every time. So why are people effing it up so much? Why are they messing this up? Well, it's because oftentimes they don't have a process. It's just willy-nilly. So let's talk through protocol integration and the process. And I guarantee you, if you follow this process that I'm laying out here, you will see massive improvements. Your boss should not come out to a job site because you can't figure out how to tie in a BACnet IP chiller. I mean, come on. How can you argue for wanting a raise and a pay increase when your boss has to come out to figure out how to tie in that Trane BACnet chiller? I mean, you should be figuring that stuff out. Okay. I know I feel like I'm being a little hard on you, but it's for your own good because these are the things that, I mean, you think this is a big deal right now. This is going to become a huge deal when supervisory controls disappear and everything's pushed to an edge controller and it's all cloud servers and smart controllers and tons of smart equipment all over the place. And then, they get the data model right. So now you're tying in lighting and AV systems. You think protocol integration is important now? Wait for 5 years from now. That is going to be the thing that determines whether you are someone who's just pulling wire or someone who is making the big bucks. So with that being said, here are the steps to protocol integration. First things first, as soon as you go and get a new job, you should read through the spec. I know it's freaking painful. I know it sucks to read through the spec, but I'm not telling you to read through all 10,000 pages. I'm telling you to read through 2 sections, usually the commissioning section and your BAS section. Sometimes you got to read through the HVAC section, but I mean, those 3 sections usually will cover everything you need. And what are you looking for here? You're looking for in both the spec and the mechanical plans to understand if they expect to have a BACnet, LAN, Modbus, whatever integration between a piece of equipment and your BAS. Once that's done, whoever's providing that equipment, you need to review their submittal. You need to understand their HVAC submittal. You need to understand whether they included the freaking protocol gateways. Because oftentimes, I mean, that's like saying, hey, I'm going to drive you to the airport, but I don't have a car. So, I mean, we're going to go and we're going to integrate data from this air handler to my BAS via BACnet, but there's no BACnet card. I mean, that is something you need to figure out right away. And then once you figure that out, you need to make sure it's the right protocol. I mean, I've seen time and time again, LAN, Modbus, OPC. For what the heck reason would you try to even do an OPC? I've seen specs written with OPC integration button from the air handler. Okay, yeah, because that's a real common protocol. I mean, seriously, what are people freaking thinking when they write this stuff? But I digress. So you've got to figure out, do we have a gateway? Do we have a protocol that we can actually interface with? And then do we have the proper data points? Now, what's often going to happen is whoever owns that equipment and that gateway is going to send you over a snippet from the manufacturer document that has every friggin' point you could possibly have. You got to push back against this. You've really got to push them and say, that's great that you show every point imaginable, but the reality is we're not going to use all these. So I need to know, based on the actual sequence, what points are going to be available and what points, more importantly, aren't going to be available. Because if you're supposed to control a zone temperature set point or district or set point, but there's no point because they don't have that capability, then you need to know that pretty early in the project. Otherwise, you're going to be sat there holding the bag when you can't pull that data point in. And they're going to be like, why can't you pull it in? You're going to be like, well, because they don't have that point. Well, you're the BAS person. Go make sure, figure it out. I mean, you guys know what I'm talking about. You've heard that before. So then once you've got that figured out, what points you're going to have, you got to be there when they actually start up the piece of equipment. It befuddles my mind how many folks do not attend job site meetings. They have no idea when the smart equipment's getting started up. They have no idea when that gateway is getting started up, and they don't show up. And then they cry and moan, oh, well, I can't get the BACnet to work, and no one knows what it was, and it's just not working. Well, were you there when they were setting it up? Did you tell them what baud rate you're at? Because you can't complain that they put it on the same baud rate or a different baud rate, or they used a duplicate MAC address when you're not giving them any friggin' information about your design. So you've got part in this too. You've got to go and be like, hey, this is the baud rate we're using. These are the MAC addresses that are available. By the way, this wire is positive. This wire is negative, etc., etc. You've got to be engaged when this is all getting started up. And, if you do those 3 things, if you make sure that you've got the gateway, you make sure you've got an accurate points list, and you're engaged when this piece of equipment gets started up, then I'm telling you, the amount of issues you will have with smart equipment will just disappear. I've integrated probably, if you name it, I've probably integrated it. And this 3-step process has never failed me. I mean, yeah, you could say, hey, but what about BACnet IP and the IT department not properly enabling BBMDs or blocking UDP port 47808? Or what if the manufacturer has 47809 and we're 47808? Okay, yeah, I get it. There are issues like that, but you can deal with those if you're engaged. You don't want to be sitting there, not engaged, not knowing that those issues even exist. Now, you do those 3 things, and you will see that the ability to integrate protocols from smart equipment is going to become massively, massively easier. Now, I hate to end this podcast episode on this note. I feel like I've been really hard on you. I feel like, you need to know this stuff, and I didn't know any other way than to just get in your face and be like, look, I see so many folks out there messing this up. And if that's not you, if you're not messing it up, great. That's awesome. Good for you. But if you're someone who's like, yeah, I'm still struggling with this, pay attention to these 5 things. Make sure you've got sequence alignment. Make sure you've got design accuracy, that you're aware of the dependent systems, that you're avoiding system segmentation, and that you're paying attention to the protocol integration and the 3 steps that make up protocol integration, which are making sure you have a gateway, making sure you got the right protocol and the data points, and then making sure that you're there when they actually go and do the startup and setup. I'm telling you folks, you figure this out. This is a powerful skill to have because, we train folks, right? Pretty sure most of you know that by now. But if you didn't, surprise, we actually provide building automation training. Yes, I know, it's amazing. But for those of you who know that, you also know that we've got a lot of friggin' students. We've had a lot of people go through our doors. And that's awesome, but that's also shown us consistently where folks struggle. And I will tell you that where folks struggle, and one of the most important and sought after skills by managers of companies, is the ability to integrate equipment. Now, you see all this stuff. Oh, we're a master systems integrator. We're a systems integrator. System is integration, smart buildings, IoT, blah, blah, blah. The reality is when plan and spec jobs hit the street, most of that stuff goes out the window. These super crazy ideas that no one can really tie an ROI to, they just disappear. They're gone. Ninja vanish, value engineering at its finest. The reality is, though, that this smart equipment and systems integration stuff right here, this is the bread and butter of the industry. This is where most of you are going to be providing value because, really, going and wiring up a resistive temp sensor, it's not that hard. Going and getting BACnet IP integration between a chiller and your BAS, I would also say it's not that hard, but a lot of folks can't do it. So if you learn these things, telling you, you'll be able to write your own ticket. It's pretty freaking awesome. Speaking of that, if you don't understand protocols, if protocols are just like mystery to you, we've got an entire course that covers protocols. It's called the Protocol Bootcamp. It's our Building Automation Protocol Bootcamp, and it's awesome. You will learn in this short, I think it's 7-hour course, every single thing you need to know about the 3 major protocols, BACnet, LAN, and Modbus. I'll include a link at buildingautomationmonthly.com/143. I really encourage you to check that out. It is an insanely valuable course. And I also encourage you to go and implement ways to avoid these 5 gotchas, and you will see tremendous results in your effectiveness as a building automation professional. With that being said, I'm so happy you're here. It's been an awesome opportunity to be able to speak to each and every one of you every week. And next week we have a awesome episode coming down the path. So many folks are confused what APIs are. So many folks are hearing about open APIs and all this stuff. We're going to dive into what APIs are, and then we're going to go through step by step how to use an API with a building automation system. That is going to be amazing. Once again, everything we've talked about is available at buildingautomationmonthly.com/143. or rather buildingautomationmonthly.com/143. I really encourage you to go there. If you are at all struggling with protocols, I can't tell you enough how much you need to invest in our protocol course. It will change your career. All right, folks, with that being said, thanks so much for being here again, and I look forward to talking to you all next week. Take care.